Test, test. Test, test. Just making sure everything's connecting. Hey, so hello everyone, and welcome to the OneClass channel. My name is Donna, and I'm a recent master's graduate in the Materials Science program at the University of Ontario Institute of Technology, also known as Ontario Tech University. So I also took my Bachelor's of Science in Pharmaceutical Chemistry at this institution as well. So today we're going to go over some commonly asked chemistry questions at the high school, college, and university level. So if you needed any help with tutoring or with your homework, then check out the links in the description below. So I'm just going to get started with the set of questions. Okay, so the first question asks, draw the product of the following reaction. I'm going to write it over here. So we have this cyclohexane group with a ketone. It reacts with H2 and platinum. Okay, so I like to analyze the reactants that are given and also take a look at the catalyst. So typically when you have H2 involved, this usually means that there's a reduction reaction that's going to happen. And there's also a platinum catalyst. And what I mean by catalyst is that it only helps speed the reaction. It won't end up being in the final product. So I'm just gonna write the product over here. And then I'll draw out the mechanism at the bottom. So this carbonyl group ends up getting reduced to an alcohol. And I'll draw the mechanism down here. Okay, so I'll just denote R as just the carbon groups. And basically, H2 comes. This bond attacks here. That bond comes back. And then you're left with your reduced product. So let's look at the answer here. So reduction of carbonyl group with H2 in the presence of platinum produces alcohol as the product. So this is correct. Go on to the next question. Okay. This is question number 2. Classify each of these reactions with respect to the following categories: combination reaction, decomposition reaction, combustion reaction, and single displacement reaction. And then they just have a whole bunch of examples at the bottom. Okay, so let's tackle them one by one. So the first one, we have this iron carbonate species. That is a solid. Then it gets heated up. Get this iron oxide group plus CO2 gas. Okay, so let's just make some points about this reaction. We have this solid that is converted to two substances. Okay, so looking at all my different options, I can say that this is a decomposition reaction. Okay, let's look at B. 2 C611. Okay, so again, I'm just going to analyze what is happening in the reaction. We have this very large carbon molecule that is reacting with oxygen to get products such as carbon dioxide and water. So already, those are all of the different things that would indicate that this is a combustion reaction. So again, these are pretty easy to identify, since oxygen is a reactant, and then CO2 and water are your products. Okay, so on to reaction C. Okay, so we have this phosphorus oxide solid reacting with water to get H3PO4. So here you have a solid that's dissolved in water that forms a solution. So therefore, this is a combination reaction. On to D. Carbon solids. Manganese solid. Under heat. Manganese plus carbon monoxide. So here you kind of notice that carbon switches places with the manganese. So this is what you would call a single displacement reaction. Okay, whizzing through these. On to the last one. So we have something similar to reaction A. You have this solid that is converted to two different substances. So therefore, this is a decomposition reaction again. Okay, let's have a look. This answer, a lot of random symbols, but place. So I don't really understand what that says. So I'm just going to write down what the answer should be. So A, decomposition. B is combustion. Okay. Okay, so that solution was incorrect. Sorry. On to question number 3. So how much energy does the electron have initially in the n equals 4 excited state? So it looks like this person answered it already, but I'm still going to go over the question just to see how they got this answer. So I'm assuming this is 1.636 times 10 to the negative 19. Part B asks, what is the change in energy if the electron from part A now drops to the ground state? So again, I'll just go over how they got that answer. And then part C, what is the wavelength of the photon that has been released in part B? So I'm guessing this is the part of the question that they actually needed help with. Okay, so on to 3A. How much energy does the electron have initially in the n equals 4 excited state? So I'm going to use this equation here, where E is equal to the energy equals RHC over n squared. So R is Rydberg's constant. H is Planck's. C is the speed of light. So these are all just constants. And then n is equal to 4 for this question. So this is the excited state. Then all you have to do is plug in all of those values. So R is equal to 1.07 times 10⁷ inverse meters. This is multiplied by Planck's constant, 6.626 times 10⁻34 joules times seconds. Speed of light, easy to remember, is 3 times 10⁸ meters per second. All of that over 4 squared. Okay, so you have to be careful with constants sometimes, because sometimes in formula sheets they give you the constant with different units. So for the ones that I inputted, I made sure that these were all the correct units. And a way to check is to see if it all cancels out properly in the end. So we want our energy to be in joules. So our meters will cancel out, and our seconds will cancel out. And then we're left with an energy value of negative 1.363 times 10⁻⁹ joules, which is the same thing person got there. Okay, so the second part asks, what is the change in energy if the electron from part A now drops to the ground state? So this means that it used to be n equals 4. So this is our initial. And n final is equal to 1, which is ground state. So now I'm going to use this equation right here, which calculates the change in energy is equal to the same constants, R, HC, and then in brackets you have 1n squared of your final minus 1 over n squared of your initial energy states. Okay, so again, I'm just going to plug in all these values. Of space. And then all of this is multiplied by 1 over squared minus 1 or squared. And after plugging all of this into your calculator, since this is the delta E, I'm only looking at the value that I get. So even though it's like a negative value, the answer we want to put in is just that the value itself. I'm just going to say 2.04 times 10 to the negative 18 joules. And you also want to be careful when you plug in large equations like this in your calculator. I've seen a lot of people that would not put their exponents in brackets, or they would just do, yeah, like you have to put brackets around everything to make sure that you get proper value in the end. Okay, so now we're on to C. What is the wavelength of the photon that has been released in part B? This is actually fairly easy as well. You have delta E is equal hc over lambda. And then we just plug in everything that we know. So delta E is what we calculated above, 2.04 times 10 to the negative 18 joules is equal to Planck's constant, which is 6.626 times 10 to the negative 34 times seconds. Speed of light, 3 times 10 to the 8 meters per second. All of that is over lambda, which is what we're trying to solve for. You fit it at the bottom here. Lambda ends up being 9.69 times 10 to the negative 8. Question asks to express your answers in meters, but I'm still going to write this down in nanometers. So this would be 96.9 nanometers. So this is the amount of energy that will be released as a photon. Okay, so let's see this answer here. For part A, yep, they got negative 1.36 times 10 to the negative 19. Part B, change in energies, 2.04 times 10 to the negative 18. So they did it a different way, but you can, okay, yeah, so they calculated their energies separately, and then after looked at the difference between the two. And then lastly, the amount of energy released as a photon, 9.7. Yep, so it's pretty much the same. Some significant figure difference, but that just depends on how many sig figs you put for constants. Okay, so this solution is correct. Okay, so on to question number 4. What is the units of enthalpy? So a pretty standard question. I'll just write down the definition of enthalpy first. So enthalpy basically is the difference between your product energy and reactants energy. So you can also write it as delta H. And the unit that you would use for enthalpy is joules. Okay, so some questions will also give you enthalpy in like kilojoules. So just make sure you know how to convert between the two. So let's just see what this answer says. Thermodynamics is the branch of science that deals with the heat and all the forms of energy. Enthalpy is the total heat content of a system. Yep, it is the sum of total internal energy plus the product of volume and pressure. Enthalpy is represented by the following equation. H is enthalpy, U is the total internal energy, E is the pressure, and V is the volume. If there is a pressure at a constant rate, then the total heat absorbed or released is equal to the change in enthalpy. Enthalpy is usually measured as a change in initial and final values as delta H equals delta U plus delta P times volume. And then the SI unit of enthalpy is joules. This answer was very well informed. It is correct. Okay, so on to question number 5. Okay, so these are one of the fun ones. Question number 5, specify the reagent you would use in each step of the following synthesis. You start off with this alcohol group. It reacts with something to get an unknown product, then reacts with something else. To get a new carbon bond formed here. And you also want to keep this alcohol group on the same carbon. So 1, 2, 3, 4, 1, 2, 3, 4. So we're looking for this intermediate, and we're also looking for the different reagents. Okay, so let's just look at the reagents that are available, and then we'll try to do process of elimination. So let's see, they give us a lot of these. Every time you have like a carbon group that's with magnesium and bromide, this is something called Grignard's reagent, and it is a helpful way to add a new carbon group to like aldehydes. So we know that we're gonna need one of these Grignard reagents in step 2. So in our case, we need one that has a phenyl group, so we can rule out this methyl, ethyl. Okay, so we're gonna need this one as our reactant in the end. So it is C6H5MgBr. And usually this is reacted with like an acid. This is something called the workup step. Just to get a feel of what this compound looks like. It's basically this phenyl group that has the magnesium bromide attached to that. Okay, so we know that this is what we need in the second step. But in order to get from this intermediate to there and react with this Grignard reagent, then this middle group needs to be an aldehyde. So this is because after this aldehyde reacts with the Grignard reagent, this carbonyl group gets reduced back to the alcohol that we started with, and then you see that there's a new carbon-carbon bond that is formed. And so now we just need to figure out how to get from this alcohol to the carbonyl group. So I'll go over all of the reagents that are given in case it just looks like a lot of random compounds. I'll show you what they all mean. So this lithium aluminum hydride is actually a strong reducing agent. So basically you would use this to form alcohols. So we can rule out that. H2SO4 is usually for the elimination of OH with heat. So we don't want to get rid of our alcohol group, we want to kind of keep it on that carbon. So we're going to rule out that. HCl is an acid. Typically when it's reacted with an alcohol, it replaces it with a Cl group, sorry. And the same thing goes skipped HBr. Yeah, similarly, HBr does the same thing, except you replace your OH group with bromine. SOCl2 does a similar thing with HCl, except it takes into account the stereochemistry. So you get an inversion of stereochemistry. So this question doesn't even ask about stereochemistry, so we can just rule out that as well. And then similarly, this PBr3 does the same thing, replaces it with Br, and there's an inversion of stereochemistry. And finally, we have something called pyridinium chlorochromate, also known as PCC. So this is actually what we're looking for here. So PCC is what will oxidize our alcohol group to the carbonyl. So that's done, but I'll still go over the rest just to finish it off. This is a base that will deprotonate the alcohol group. And it's used to form ethers. The NaOH. It also reacts, it's also a base. It tends to form aldehyde enolates. And it does that by reacting with another molecule of aldehyde. So this is something called the aldol reaction. And I'm going to skip all those Grignard reagents, sorry. And then lastly is chromium tri oxide. This is something that you would use for Jones oxidation. So this is a very strong oxidizer, and it will convert your OH all the way to carbon hydroxide, or ketones if it was in the middle. Okay, so let's see. The answer says here, step 1, pyridinium chlorochromate. Step 2, phenylmagnesium bromide. Solution is correct. And on to question number 6. Determine the major organic product for the following reaction scheme. If no reaction, draw the starting material. So we have this phenyl group that has a methyl and a bromine attached. So let's do this step by step. So the first part has 2 lithium, and basically what this does is that it converts your alkyl, it converts it into an alkyl lithium compound. And then you get products that look like this. Let me just write that down. Your alkyl halide converts into alkyl lithium. Okay, so that's first part of the question. So now we have this alkyl lithium group here reacting with copper iodide, and there's 0.5 equivalence. And there, I'm gonna write that there are 2 equivalents of this, because I'll show you why. Actually, I don't need to write 2 equivalents because they... Okay, so the reason it's 0.5 equivalents of the copper iodide is because you end up with a complex that looks like this. So you have 2 of our starting groups that react with like a copper in the middle. And this is what's called Gelman's reagent. So it can be any R group. Okay, so after you have Gelman's reagent, the point of that is that, sorry, this is a very good nucleophile. here. The file. And what happens is that it reacts with our electrophile over here. And then you end up with this as your final product. Okay, so let me just summarize what just happened here. So the Gell-Mann's reagent so typically it reacts with alkyl halides. So primary or secondary alkyl halides. It doesn't react with any tertiary. So it forms cross product, alkane. Okay, so this is our final answer. And yep, not as detailed, but that is the correct answer. Now we're on to question number 7. Identify the peptide bonds in this structure by clicking on them. So I can't click on them, but so I'm just going to identify the peptide bonds structure. So let me just write this whole thing down. This is question number 7. And then you have this is like a biochemistry question. All the different kinds of amino acids. So it looks intimidating, but the more you start to work with amino acids, you kind of get used to them and see a pattern. If you take like biochemistry in university, like they make you memorize all of the essential amino acids. So it's not fun, but you know, it's doable. So almost done here. So when you have a chain of amino acids, you'll start to notice that they all contain an amine group, and then like a carbonyl group. And then what makes all of the amino acids different is that they all have different R groups, which are shown here. I'll just put these in squares so that we can identify them later. Okay, so first we'll just do what the question asks and identify all of the peptide bonds. I'll just write down what peptide bonds are. Basically, they include your carbonyl group, or carboxyl group, sorry. Of one molecule. With the amino group of the other molecule. So in this case, we can identify it here. So this is a peptide bond. This is another one. I'm not going to circle the last one. So these are the peptide bonds. And then if you want to identify the amino acids, this first R group is from glutamic acid. This is, pretty sure this is isoleucine. Let me see. Okay, yeah, so it's leucine. Just needed a refresher on that. And then the last one should be serine. And then if you wanted to write down their abbreviations, it's GLU, SER. Okay, so I know that this person got it right here. Peptide bonds are the chemical bonds which are formed between two molecules. Carboxyl group of one reacts with the amino group of the other. And they circled the correct peptide bonds. Answer is correct. Okay, so on to question number 8. Select the IUPAC name for the following cycloalkane. Let's write this down. Okay, so when you name your molecules, you want to find out what the parent is. So in this case, it is our cyclo group. Color didn't change. Okay, so this is our parent. And I count 1, 2, 3 carbons. So I know that it is cyclopropane. So the prop is because there are 3 carbons. And now I'm going to look at the side chains. So we have a methyl group here. And then we have an ethyl group there. So I'm going to say that this is carbon 1 because you want the lowest number possible when you name things. And then this is ethyl. This is a methyl group. And then you want to list them in alphabetical order. So it's going to be 1 ethyl, and then 1-methyl cyclopropane. Okay, so let's see if that option is here. So they have 1-methyl, 1-ethyl cyclopropane, 1-ethyl, 1-methyl. So this is what I said. 1,1-methyl ethyl cyclobutane. So we know that that's wrong because this was what you would get if it was a 4-membered ring. And then there's also 1-ethyl, 1-propyl cyclobutane. So butane's not even like a name. And we know there's no propyl group there, so by process of elimination, it is option B. Ethyl cyclopentane. So I think this person might have looked at a different question. Yeah, maybe there was something, maybe a technical difficulty on this person's part. Yeah, they must have gotten a different question altogether. They say it's a 5-carbon ring. But the answer sounds right for whatever compound they've got, but I'm just gonna verify it here. Answer is 1-ethyl, 1-methyl cyclopropane. And then I'll just say why. 3-membered ring. Is where cyclopropane came from. Ethyl group on carbon 1. Also a methyl on carbon 1. Okay, so this solution was incorrect, unfortunately. Okay, so those are all the questions that we had today. I hope you enjoyed today's Q&A, and if you did, then hit the subscribe button below and also the notification bell if you want to be notified of when these videos are posted. So if you like the video, then give it a thumbs up and leave a comment, and share it with all your friends and classmates to see if they needed help with any of their chemistry assignments. So this has been Donna from OneClass. I hope to see you soon. Goodbye.